Welcome back to the deep dive. This is where we take concepts you think you know, maybe pretty well, and we peel back the layers.
And find something completely unexpected underneath.
Exactly. Today, we're plunging into a realm that, well, for many of us, it got filed away after high school. Prime numbers.
Ah, yes. Good old primes.
Right. We often think of them as these isolated, almost quirky integers, numbers that just, happen to not be divisible by anything other than one in themselves.
2, 3, 5, 7. Onwards and upwards.
Yep. Stretching into infinity. But what if that conventional understanding is just the very, very tip of the iceberg?
Or maybe just scratching the surface of something much, much deeper.
Precisely. What if primes are, well, far more fundamental?
Yeah.
Almost, dare I say, mystical, acting as the very skeleton of reality itself, not just arithmetic.
That's a powerful way to put it.
Okay, let's unpack this. Because what we're about to explore today, it might just fundamentally shift your perspective on what a number truly is.
What's truly fascinating here, and really the core of our exploration today, is that we're not just looking at the mathematical properties, not in the usual way.
Right, not just the how they divide part.
Exactly. We're stepping into a pretty profound philosophical and mathematical framework. It's known as ontological mathematics.
Ontological mathematics.
And our deep dive today is specifically guided by the groundbreaking insights of Philip Randolph Adam Lilien. We're drawing heavily from his key work, Prime Resonance and Ontological Irreducibility.
Okay, so that's our main source text.
That, and also a comprehensive briefing document that really summarizes its core ideas. Our mission, if you like, is to extract the profound, almost dizzying implications of viewing primes through an ontological lens.
Seeing them not just as numbers, but as something else.
As fundamental components of what Lilien calls coherence. Now, this isn't about crunching numbers, not really, or solving equations. It's about understanding the deep why behind them.
Moving beyond just arithmetic curiosity.
Way beyond. We're looking at their potential as the very underpinnings of, well, physical law. The structure of reality itself. It's quite a journey.
That shift in perspective, that's what makes this so captivating, I think. Most of us learned the basic definition: prime number, natural number, greater than 1, no positive divisors other than 1 in itself.
Simple, elegant. Seems complete.
Seems complete, yeah. But if we're following Lilien here, that's like describing a human being merely as, I don't know, a collection of chemical elements.
Accurate, maybe, but it misses everything essential.
Exactly. So the question isn't just what they are by definition, but what are they in existence? Is it just a classification based on divisibility, or is there something deeper, some ontological significance?
Well, from the perspective of ontological mathematics, it's not just significant, it's foundational, absolutely foundational.
Okay.
Lilien makes it very clear that primes are not merely numbers that can't be divided in that familiar arithmetic sense. That's really just a consequence of their true nature.
A symptom, not the cause.
Precisely. Ontologically, he states they represent, and this is a key phrase, points where coherence condenses into indivisible resonance.
Okay, whoa. Let's break that down. Coherence, what does that mean here?
Right. Crucial term. When Lilien talks about coherence, we're not just talking about, logical consistency or things fitting together nicely. In this framework, coherence is, well, it's the ultimate underlying reality or structure.
Like the base layer of everything.
Pretty much. The fundamental self-consistent fabric from which everything, numbers, physics, even consciousness perhaps arises. It's the intrinsic order of existence itself.
Okay, so coherence is this fundamental fabric. Then primes are points where it condenses. What does that imply? Like specific spots where this reality gets solid, stable.
Exactly, you've got it. They are where this intrinsic order becomes manifest in an irreducible foundational form. It crystallizes, so to speak.
And the second part, indivisible resonance. That sounds like more than just can't be divided by 2.
Oh, much more. It suggests a fundamental, stable, energetic, or structural node that cannot be broken down into smaller components within this ontological system.
So it's not about factors in arithmetic. It's about fundamental building blocks.
Yes. Imagine a perfectly tuned, singular musical note, one that you just can't deconstruct into other frequencies. That's closer to what Lilien means by indivisible resonance.
An energetic stability, an inherent wholeness.
Exactly. It's profoundly different from saying you can't divide 7 by 2 without getting a fraction. It's saying the number 7 itself, ontologically, cannot be broken down into more fundamental numerical constituents, not in the way a composite number can.
That's a huge leap.
Oh.
So numerically indivisible is one thing, but this is structurally, fundamentally indivisible, at the core of existence almost.
That's the idea.
How is that different from, say, breaking a molecule into atoms? Are primes the atoms of this numerical reality, or something even more basic?
You're definitely on the right track with the atoms analogy. Lilien uses similar ideas, but maybe pushes it even further. He describes primes as ontological anchors.
Anchors.
Yes. The text states they puncture the number line with irreducible resonance. It's a very vivid image, isn't it?
Yeah, it really is. Like, they're not just on the line, they're holding it together.
Precisely. Stable foundational points within the very fabric of numbers, almost like structural rivets, as you say. They aren't just generated or derived from something simpler, they emerge as these stable nodes.
Okay, so they emerge. How does that contrast with composite numbers, like 4 or 6 or 12?
Well, composites numbers like 4, 6, 8, 9, they are described as being generated by combining smaller eigenmodes.
Eigenmodes. Okay, physics term creeping in. What does that mean for numbers?
Good question. Think of how a musical instrument vibrates. A guitar string, right? It has specific fundamental ways it can vibrate. Its basic, inherent forms of motion that produce its notes. Those are its eigenmodes.
Like a pure note.
It's a pure notes, exactly. You create complex sounds, chords, by combining these fundamental vibrations. But the eigenmodes themselves, they're the irreducible forms. So when Lilien says composite numbers are generated by combining smaller eigenmodes, he's implying that a number like 6, which is 2 times 3, is like a chord. It's built from the fundamental notes or vibrations of 2 and 3.
And the primes, like 2 and 3.
The primes, then, are those fundamental, irreducible notes or vibrations themselves. They can't be broken down further into simpler numerical modes within this system.
Wow. So composites are products, structures built from primes. Primes are the original sources, the elements.
Exactly. That's the critical distinction. It really redefines our basic understanding of what a number is. It suggests some numbers are truly elemental, existing independently as these primary points of coherence.
And this ontological view, does it explain why primes keep appearing? Why they don't just stop after a while?
Yes, it does. It explains their universality. No matter how far you count, primes continue to appear precisely because they are these fundamental points of coherence. They're not diminishing constructions that eventually run out.
They're intrinsic to the structure. Always being generated, or always there.
Always potentially there, continuously manifesting these irreducible points as you move through the number sequence. They are perpetually present because they are fundamental.
That's a powerful idea. Numbers as elemental building blocks. It really does make you think about how complex structures are built from simpler components everywhere else.
It does.
So if primes are these indivisible resonance nodes, these fundamental notes, how do they actually relate to all the other natural numbers, the chords, the symphonies? What's the connection?
Well, that brings us to another really fascinating concept Lilien introduces, the prime skeleton.
The prime skeleton, okay, I like that analogy, like the bones of a body giving shape and support. Without the skeleton, you just have, well, blob.
That analogy is incredibly apt. Lilien uses very similar imagery to drive this point home. The concept of the prime skeleton highlights that primes form the actual underlying structure of all natural numbers.
All of them, every single one.
Every natural number greater than 1. He states, and this is crucial, every natural number decomposes uniquely into a product of primes. This is not an arbitrary theorem, but an expression of ontology.
Okay, so he's talking about prime factorization, the fundamental theorem of arithmetic, right?
Exactly. That's the mathematical cornerstone. It proves that every number greater than 1 is either prime itself or can be uniquely written as a product of primes. 12 is 2 times 2 times 3, and only 2 times 2 times 3.
You can't factor it any other way using primes.
Right. That specific set of primes is 12's unique identity. But here's the ontological twist. In this framework, it's not just a mathematical proof or a convenient tool, it's presented as a fact of existence.
A fact of existence, meaning it's how numbers are fundamentally constructed in reality.
That's the claim. It implies a deep, inherent architecture within the number system itself, where primes are the very blueprint. It's how numerical reality is actually built.
So the number 12 isn't just a quantity. It has a specific, unique structural signature defined by its prime factors 2 and 3. That's actually mind-bending.
It is. And Lilien carefully defines the roles within this skeleton. Composites, like 12 or 30, are described as resonance compounds, structured by prime nodes.
The resonance compounds.
They are the more complex forms, the structures built from the primes. Take 30. It's a composite, sure, but its essence, its coherence, comes from that unique combination of the prime nodes 2, 3, and 5. It's a specific compound resonance of those foundational elements.
And the primes themselves?
They are the resonance roots, indivisible seeds of structure. They are the irreducible foundational elements, the very bones themselves, going back to your analogy.
The roots, the seeds, the bones. Got
Yeah.
it. Lilien uses some powerful analogies himself, doesn't he?
He does. He says, numbers are built upon primes the way molecules are built upon atoms. And also, the prime sequence underlies the natural sequence the way bones underlie flesh.
Those really help visualize it. So back to 12. It's 2 times 2 times 3. It's a resonance compound, intricately structured by its resonance roots, the primes 2 and 3.
And crucially, the unique combination and repetition of those specific prime roots give 12 its particular identity and coherence within this grand numerical scheme.
Here's where it gets really interesting. As we start to see how everything, every single natural number, is constructed from these basic irreducible units, it's like a foundational blueprint for all quantity and structure.
Exactly. And this foundational structure then leads us to look at the pattern of the primes themselves. How are these bones arranged?
Right, because for centuries, people have looked at their distribution and, well, it seems pretty chaotic, doesn't it?
To the casual observer, absolutely. They often appear scattered, almost random along the number line. There isn't an obvious, simple formula that just tells you where the next prime will pop up.
Which is why it's such a famous mathematical puzzle. This seeming unpredictability. Has it led people to think they're just random?
Many mathematicians have certainly viewed their appearance as chaotic, yes. A deep mystery yet to be fully deciphered.
But does this apparent randomness actually conceal a deeper pattern? Is there maybe a secret rhythm to their emergence that we're just not quite getting with our usual tools?
According to Lilien, absolutely there is. He argues very strongly for this. He explains that while primes are indeed distributed irregularly to the casual eye, a deeper analysis shows rhythmic tendencies.
Rhythmic tendencies. Okay, so not a simple beat, but something more complex.
Exactly. This isn't about finding a simple linear formula that spits out the next prime every single time. It's about recognizing a complex underlying order, a dynamic harmony hidden within their distribution.
Can you give some examples of this rhythm?
Sure. He points to several specific things. First, consider prime gaps, the spaces between consecutive primes.
Like the gap between 3 and 5 is 2, between 7 and 11 is 4.
Right. These gaps aren't uniform. They oscillate, sometimes close, sometimes wide. The gap between 2 and 3 is just 1. Between 113 and 127, it's 14. They vary. But Lilien argues this isn't pure chaos.
It's an undulating pattern.
Yes, a dynamic dance rather than just a static random arrangement. Think of it like a heartbeat. Maybe irregular, but still a consistent, if varied, pulsation, not just noise.
Okay, so not a steady drumbeat, but a consistent, if complex, pulse. That makes sense. Even complex systems often have underlying rhythms.
Precisely. Then there's the really fascinating phenomenon of twin primes.
Pairs of primes that differ by just 2,
Yeah,
right?
right,
Like
very
3,
cute.
5, 5,
Yeah,
something like
17, 19, 29, 31, and so on. Their emergence, even though they seem to get rarer as numbers get larger, is described as paired resonance peaks.
Paired resonance peaks, that suggests harmony, connection.
It strongly suggests a harmonious pairing within this coherence framework. It indicates that certain prime nodes have this natural inclination to appear close together, creating these resonant couples, as if coherence itself likes manifesting these specific, closely related stable points.
Interesting. So oscillating gaps, paired peaks, anything else?
Yes, the overall prime density. We know that primes generally become less frequent as you go higher up the number line. They thin with growth.
Right. The prime number theorem tells us roughly how they thin out.
Exactly. But crucially, the theorem also confirms they never disappear. They keep appearing indefinitely. This indicates a consistent underlying presence despite becoming sparser.
They're always part of the fabric, even if spread further apart.
Always there. This continuous, albeit thinning emergence is another facet of this deeper rhythm. It confirms their status as fundamental points of coherence.
So this overall rhythm, this complex dance of oscillating gaps, harmonious pairings, and this consistent, if thinning, density, how does it all connect back to that big idea of coherence, this fundamental reality? You mentioned deep law guiding it.
This rhythm, according to Lilien, reflects coherence itself. oscillatory, irregular on the surface, yet guided by deep law. And this is where the ontological mathematics perspective really diverges from a purely statistical view.
How so?
It suggests that even the apparent unpredictability, the irregularity in prime distribution, isn't truly chaotic. It's actually part of a larger, profound, structured dance. And it's dictated by these deep laws of coherence.
The universe's own intricate choreography.
You could say that. The numerical universe isn't arbitrary, it's dynamically ordered, which of course. This raises an important question. Where do these deep laws truly reside?
Are they just abstract math rules or something more fundamental?
Lilien's framework strongly suggests the latter, that numbers are a direct manifestation of an underlying coherent reality, and these deep laws are expressions of that reality. It's almost like we're looking at the brainwaves of the universe. They might seem erratic at first glance, but there's a profound underlying intelligence or structure dictating their pattern.
That's a mind-bending idea.
Yeah.
Numbers not just following rules, but actually embodying deep fundamental laws. Wow.
It is.
And speaking of deep mathematical concepts revealing fundamental truths, we probably need to talk about the Riemann zeta function.
Ah, yes, the Everest of number theory.
Right. Now, don't worry, folks, we're not going to try and solve it here. That's way above our pay grade.
Definitely.
But we are focusing on its ontological interpretation and Lilien's work, which he argues is incredibly significant. Just for context, it's this function that connects all the natural numbers to just the primes. It has two famous forms.
A sum over all natural numbers, 1 plus 12s plus 13s plus staying, and a product over all prime numbers, 1, 1, 2, or 1, 1, 3s.
And the fact that these two seemingly different things are equal the Euler product identity, that's the key part here.
Yeah, indeed. The Riemann zeta function, especially that Euler product form, is absolutely central to understanding the ontological role of primes in this view. It's truly remarkable because it shows this direct, profound connection between the entire infinite set of natural numbers and the seemingly sparse set of prime numbers.
It links the whole structure to its foundation.
Exactly. And Lilien puts it this way. The Euler product expresses coherence as a network of prime nodes.
A network. Okay, what does that imply? Coherence isn't just isolated points.
Right. It implies that the fundamental underlying reality isn't just a collection of disconnected points, but a deeply interconnected system, like a vast cosmic web.
So the prime nodes aren't just sitting there alone. They interact, connect.
They form this vast, intricate web of foundational stability. This mathematical identity, the Euler product, isn't just some clever algebraic trick. Lilien presents it as a fundamental statement about how primes interrelate and collectively constitute the entire system of coherence, the very fabric of existence.
So the primes are the individual lights, maybe, but the Euler product shows us the entire illuminated grid, the whole interconnected system.
That's a great way to put it. It reveals the complex, beautiful, interconnected system. The blueprint comes alive.
And any network needs stability, right? Things need to hold together.
Precisely. And this brings us to a very specific and deeply mysterious feature within the zeta function's geometry. It's called the critical line.
Ah, yes, where the real part of the input is 1/2.
That's the one. Now, without getting totally lost in the complex analysis mathematics, Lilien's interpretation is, well, quite groundbreaking. In ontological mathematics, this critical line represents the boundary where resonance flows remain stable.
Resonance flows. What are those? Like the dynamics within the network.
Exactly. The dynamic interactions, the energetic movements, the structural relationships within the numerical system, and by extension, within reality itself, these are the resonance flows.
So the critical line is the ultimate equilibrium point.
It's essentially where these flows maintain their perfect balance and order. It prevents the system from collapsing into chaos or sort of exploding into uncontrolled expansion. It's the stability axis.
Like a cosmic balance beam, which makes the Riemann hypothesis the ultimate test of whether the universe is actually balanced on that beam.
You've absolutely hit on the profound implication. The Riemann hypothesis, one of the greatest unsolved problems in math.
Huge prize money waiting for whoever solves it.
Well, indeed. It states that all the interesting zeros of the zeta function, the points where the function equals 0, lie precisely on this critical line, this Ries equals 12 line.
And Lilien says this isn't just math.
He elevates it completely. He says it becomes not a technical conjecture, but a statement of resonance stability. Coherence flows balance perfectly when primes are viewed as irreducible nodes.
Wow. That's an extraordinary claim. So if RH is true,
If it's true, it doesn't just confirm a complex mathematical property. It implies that the entire system of coherence, fundamentally structured by primes, is perfectly balanced, inherently stable, in this very specific, beautiful way.
the structure of numerical reality is exquisitely poised.
Exactly. If the zeros were off the critical line, it would suggest a fundamental imbalance, some kind of instability at the very heart of coherence.
So what does this all mean? It means the very stability of our numerical reality, and maybe even our physical reality, could be encoded right there, in that function and that hypothesis.
That's the profound implication. It suggests the Riemann hypothesis is a key to understanding the universe's fundamental architecture and its inherent stability. It's a testament to the idea that these deep mathematical truths aren't just abstract games, they might be reflections of universal principles.
That is truly profound. The balance of everything reflected in prime numbers and this one complex function. It makes primes seem less like static numbers on a list and more like dynamic events, or like you said earlier, pulses.
Pulses of creation and stability?
Yeah. It brings us to this idea Lilien develops, thinking of primes as ontological pulses. This seems to synthesize everything we've discussed, their irreducibility, their rhythm, their role as the skeleton.
That's an excellent synthesis, yes. And it's exactly how Lilien describes them. He really elaborates on this idea of primes as ontological pulses. Each prime, in this view, marks a condensation point where coherence stabilizes.
Okay, say more about that. Condensation point.
They aren't just arbitrary numbers on a line. They are moments or specific points where the underlying coherence, that fundamental intrinsic order of reality, manifests and solidifies into an irreducible, stable form.
Like the universe taking a breath, and with each exhale, a prime number solidifies into existence, a point of perfect, unbreakable order.
That's a beautiful way to imagine it. Each prime is a kind of anchor point where the universe's foundational structure briefly crystallizes, a momentary, perfect manifestation of coherence.
And because there are infinitely many primes, this process is continuous. It never stops.
Exactly. Their infinite sequence isn't just an endless list. It represents the endless renewal of irreducibility. It implies that the fundamental, unbreakable structure of reality is continuously regenerated, continuously expressed throughout the infinite expanse of numbers.
It's an ongoing process, a ceaseless affirmation of stability.
Right. Every new prime discovered isn't just another number to add to the list. It's another unique pulse, another condensation of coherence, reaffirming the universe's inherent order.
And this perspective, does it also explain why they're so hard to predict? Why there's no simple formula?
It does. It helps clarify why they resist prediction by simple formulas. They are not generated by formulaic repetition. If they were, well, we probably would have found that formula by now. The mystery would be over.
Makes sense. So if not by formula, how do they appear?
Lilien states they are expressions of coherence corridors that cut through the infinite potential of numbers.
Coherence corridors, that's another striking image. What does that suggest? They're not random, but following pathways.
Exactly. Pathways or channels dictated by a deeper, more organic order within the numerical realm. It suggests primes aren't just appearing randomly like scattered dust. They're carving out or following these corridors.
What is a corridor in this sense?
Yeah.
A path, a region, a set of guiding rules.
It seems to be more than just a path, maybe like a fundamental architectural feature of coherence itself. Think of invisible guiding principles within the vast ocean of all possible numbers. Primes aren't just appearing randomly. They follow these corridors, a kind of predetermined fundamental structure that dictates where stable points of reality, these irreducible resonance nodes, can emerge.
So it's a deeper, more organic process than just an algorithm could capture.
That's the implication. It's the deep resonance of coherence itself, dictating their appearance, guiding their placement, which makes them seem unpredictable to our limited algorithms, but perhaps utterly necessary and predictable from the perspective of the underlying coherent system itself.
What's fascinating here is that idea again. What looks like chaos gives way to a deeper, more fundamental order, an inherent intelligence almost, within the numerical system.
An ordered spontaneity, perhaps.
Okay, so if these mathematical structures, these primes, are so fundamental, so deeply woven into the fabric of number, it just begs the big question, doesn't it?
The ultimate question.
What if they're also fundamental to reality itself, to physics? This takes us into these speculative, maybe, but utterly compelling territory. The potential role of primes in physics, as Lilien proposes.
This is definitely where ontological mathematics makes its grandest leap, extending these numerical insights right into the physical realm.
Could these numerical bones, these pulses of coherence, actually connect to the laws governing our physical universe? Could primes be a key to unifying physics?
Well, consider this. If primes are indeed these eigenmodes of coherence, those fundamental irreducible vibrations we talked about,
The pure notes.
the pure nodes, then Lilien suggests they may correspond to fundamental particles or fields.
Whoa, seriously, like electrons, quarks.
That's the staggering implication, that the basic building blocks of matter and energy, quarks, leptons, maybe the underlying quantum fields, could be direct, physical manifestations of these numerical primes.
So a specific prime number, like 2 or 3 or maybe some enormous prime, isn't just abstract math. It embodies the vibrational frequency or the structural integrity of an electron.
Or a photon. Imagine that possibility. It's a profound idea, connecting the abstract world of number directly to the concrete world of matter and energy.
So a fundamental particle might, in some very deep sense, be a prime number made manifest. That's incredible. It completely reframes the search for fundamental reality.
It really does, shifting it from purely empirical observation towards a numerical and ontological quest. And the connections don't stop there.
There's more.
Lilien also suggests that the prime rhythms could map onto energy levels, quantum oscillations, or field resonances.
Back to the rhythms, the oscillating gaps, the twin primes.
Exactly. Those observed hidden patterns in prime distribution, they could directly relate to the periodic or oscillating behaviors we see everywhere in physics.
Like in quantum mechanics.
Yeah.
Particles in discrete energy levels.
Precisely. Those discrete energy levels could be like the distinct resonance nodes of primes. Or think about field theory, where fields oscillate with specific frequencies. What if these physical rhythms and oscillations are direct echoes of the underlying prime rhythms that govern coherence itself?
It's like the universe is playing a tune.
A numerical symphony playing out.
And the primes are the fundamental notes and chords making up that melody, from the tiniest quantum scales to the largest cosmic structures, implying this deep underlying harmony between math and physics.
Absolutely. And this leads to the ultimate implication, the truly unifying vision, Lilien states. The universality of primes may thus underlie the universality of natural law itself.
Okay, unpack that. The universality of natural law.
It proposes a profound unification. The same fundamental structure that governs numbers, that creates the skeleton of arithmetic, could also govern the laws of physics. Everywhere, across the entire cosmos.
Meaning the rules of the universe, gravity, electromagnetism, quantum mechanics, are all expressions of the same underlying prime-based coherence.
That's the grand vision. If we connect this to the bigger picture, this could fundamentally alter our search for a unified theory of everything. It suggests the roots lie not just in geometry or forces, but in the very essence of number itself, conceived as this manifestation of fundamental coherence.
It opens up a completely new way to think about the universe's fundamental rules. What an absolutely incredible journey we've taken today.
It really covers some ground, doesn't it?
We started with what seemed like such a simple, almost mundane definition from, elementary school. A prime number is just only divisible by 1 in itself.
Simple definition, profound reality.
But we've totally transformed that understanding. We've seen them as irreducible resonance nodes, the very skeleton of all natural numbers, dynamic pulses of coherence, and potentially the fundamental building blocks of physical reality itself.
They are far, far more than we typically imagine, embodying a fundamental active structure of existence.
Yeah.
So our deep dive today, it really culminates in understanding primes as the irreducible resonance nodes of mathematics, the skeleton of number, the pulses of coherence itself. To view primes this way is, well, it's like glimpsing coherence at its most indivisible point, seeing the foundational stability that everything else is built on.
Both numerically and maybe physically.
Potentially, yes. And Lilien's work, as we've explored, it doesn't stop with primes. He hints that the next chapter, the next stage of this exploration, expands this insight into the realm of the irrationals, numbers like pi or the square root of 2.
Okay. How do they fit in?
He suggests that with irrationals, coherence unfolds not in these discrete, stable nodes like primes, but in infinite cascades of resonance.
Infinite cascades, so more like flows.
Exactly. They serve as the fluid dynamic counterpart to the discrete, rock-solid prime skeleton.
Wow. Okay, that is a truly provocative thought to leave everyone with. What does it mean for reality to have both? These discrete, irreducible anchors the primes, and these infinite cascading flows of coherence like the irrationals.
How might these two seemingly opposite concepts, the solid structure and the ceaseless flow, complement each other? How do they work together to form our reality, structuring everything we perceive and interact with?
What kind of echo of these mathematical principles, the discrete and the continuous, the stable and the flowing, might you find in your own everyday experiences, or in the science you read about if you look closely enough?
It certainly gives you a lot to ponder. We invite you to mull over these questions and just keep an open mind to the hidden depth that might lie beneath the surface of reality. Thank you so much for joining us on this.
Well, this truly mind-expanding journey into the secret skeleton of numbers.
Keep digging, keep questioning, and keep exploring the deep dives that are all around you. We'll see you next time.